Mike Swartz. So I'm a recently retired orthopedic PA. I worked 31 years in the military, infantry, special forces, medical side. And so I've kind of been all over the place, deployed to 5 continents. And I've done a lot of water purification as I've had to go around different places and had to be very cognizant about, what we put in our mouths. And so I just wanted to overview this as quick as I can here today, and see if we can gather some information. Can you guys see the slide? Is that posted up?
No slide yet. You get to screen share.
Share screen. Yeah, and there it is. Okay, so I'm going to be doing some off the slide here, and then some of this is be demonstration. So the first piece I'm going to kind of breeze through a little bit quick. Finding water in the wilderness. Everybody's going to get a copy of this handout, so I don't want to read it to you. But basically, you can use wildlife as a clue to figure out where water is when it's nearby. You can watch the birds, you can watch the bees, and it explains that in the first 2 paragraphs there. There's different ways of finding water when you're at your home and you're looking at the wilderness areas around you. You can get county maps and things like that and see what the water table looks like and see what the surface water looks like. You can get county maps and look and see where wells are and things like that that might be in your area. Those are all recorded. But if you're truly in a very remote area, you've got to look at the terrain and see where water has been, and see if you can find it at those locations. Some tricky ones, when you're at the beach, there's a slope of the beach, and then typically there's a berm represented by my head here. There's a little lump of sand, and then just the other side of that blown up berm is usually where you'll find some water. Now the trick is salt water is heavier than fresh water, and so it'll tend to layer out. And so when you're digging down for that water, you want to stop as soon as you hit the fresh water so you don't disturb it and mix the salt water from the deeper layers. Another key aspect in the wilderness, especially in really arid areas, is water conservation, moving at night, and then hunkering down in the daytime, preferably with a double layered shelter, so that you can limit your water consumption or water wastage. When you're pulling water in the wilderness, you want to be very careful. The best place to get the water would be surface lakes. A lot of people have spread this rumor that moving water somehow is purified in a river. And if you believe that, then pour some dirty water into a glass jar with rocks and shake it up until you feel it's clean, and go ahead and drink that. See how that works for you. So water is a challenge for us because it can transport contamination from great distances that we can't really see or readily appreciate. And so as we're accessing this water, just recognize that it can be contaminated, particularly in disaster settings when we don't have the enclosed sewer systems that we're used to. And as we become a third world country, and sewers are open and people are all over the place, that almost every source of surface water is going to be contaminated in a really bad way. Some of the safest ways to get water is to look at lakes or still water, actually. And if you are accessing water there, you'll find most of the viral contamination is actually right there at the top 6 inches, or the top few inches, rather, and right at the air to water interface. And most of the bacterial contamination will settle out over time down to the bottom of that lake. And so you want to avoid the sediment as best you can. Sediment also is death to filters. So you want to get your water, at least 6 inches or so below the surface is the answer there. In rural settings, we talked about the county maps. A simple well pump is the one that we've installed in our well. It's basically a little bit of a spendy device, but when the power's off, I can go out and crank a handle, or I can throw up 2 small panels and run it off of 12 volt and get some basic pressurized water during the daytime. My well's it has a lot of water in it. It's pretty close to the surface. You can get 4 to 5 gallons a minute pretty easily, and that's enough to run a drip system in the garden and supply some basic water supply to the house. If that's not working, or you can't afford a simple well pump because they are expensive, a well bucket is a device that you can make. And basically all that is a check valve. If you look on a well, you'll see where the pipe comes up out of the well vertically, and then it typically takes off sideways. And usually there's a brass valve within a few inches of that. And that's a check valve. And basically what it has is a one-way valve in it, so that water can flow out of the well, but it can't flow back down into the well after you've pumped it out and pressurized it. If you take that and thread it on the bottom of a long section of pipe, you can lower it down into the 6-inch opening of the well after you've pulled all the other contents out. And when that check valve hits the water, it will open up and allow the water to fill that very long, inch and a quarter or 4-inch, or depending on what pipe you have, size bucket. It can be 10 feet long, and it's just a long, skinny bucket, and you can actually fill with water and go from there. I need to be able to scroll through the share, actually. Thanks. Can you guys see me or the share right now?
I can see you right now.
Okay. You can't read the screen. Okay, so you guys can't read the text. Is it too small or? All right, I'll keep going.
When you're sharing, we can read it, but now we're just seeing you and not the share.
Okay, so let's get back to sharing. Jen, you want to help me with that while I'm talking? Thanks. No, can you get, it's not sharing right now.
I understand
Sorry,
that.
dear.
I'm zooming in so they can see.
Okay, great. Thank you. Screen share. Thanks, dear. All right, is that better? Okay.
Yeah, that looks great.
Okay, great. So, all right. So once you get that well bucket down into the well and it's filled with water from the bottom through the check valve, when you go to hoist it back up again, it's going to retain that water because the check valve won't let the water drain back out the bottom. You can hoist it up. If you set up a tripod above that, it makes the process a lot easier. You basically, lift it all the way up and put your finger up in the check valve and release it, and it'll dump all the water out of that big, long, tall bucket. Spreading out a tarp so that the rope you're using has some clean place to set is also a good technique with that as well. And so that allows you to access well water that otherwise wouldn't be available. When we're talking about water purification, one of the things that we're always trying to do is get the cleanest source of water to start with, and then fix it from there. And well water is typically a very clean source of water to start with. And so in urban settings, we have other sources of water to include the plumbing in your house. If you can open up a low fixture in your house and then open up a high fixture in your house to allow the air to come in, you can drain the plumbing in your house of water. There's water in the hot water tank, of course, in the toilet tank, of course, behind the toilet. There's water in your pool and hot tub for washing purposes, but if you've used any kind of algicides with copper in it, it's really not something that you're going to want to drink or try to purify. Farm and pond water can be purified. Of course, it's quite contaminated with farm runoff, and the septic tank can even be purified, but that's really about as nasty as it gets there. And there may be chemicals from the home depending on what's been used in the home as far as soaps and things like that. When you're getting into really dense urban areas, outdoor spigots on some large buildings will be present. You need to have a wrench or a multi-tool to access those. There's specific wrenches that will fit those. High-rise buildings have check valves. And so if you're an apartment dweller or you're living in a very, or you find yourself in a very tall building like a hotel, if you drain the water, similar as we talked about draining out of the pipes, you can get a lot of water, but you're only going to get a few floors. And so you got to go up a few floors to bypass the check valves, and you can find more water as you go up the building. In dense urban areas, if you find a gas station or industrial site, oftentimes they'll have what's called a groundwater test well. And what that is so they can sample the groundwater to make sure they don't have a leak in their fuel tanks. So presuming that they don't have a leak in the fuel tanks, you you might be able to access that water. When you open up the well casing, you're going to find a pipe in there. That pipe has an inertial pump at the bottom of it. You shake the pipe up and down, and it moves a piston based on the inertia up and down, and starts moving that water up the pipe, and it'll start overflowing the pipe. And that's how you can get the water out of those industrial groundwater test wells. Storm drains, can have trapped water, but again, multiple contaminants. It's street runoff. It's really hard to purify, and potentially a pretty rough starting point there. Fire hydrants are a good option, especially if there's any kind of slope to the area. Again, you can crack the cap and open the valve and fill any kind of container that way. Keep in mind that it's kind of like this course. It is a fire hose, and so be prepared to get a lot of water, and be prepared to shut it off real quick so you don't waste that supply. But there's an awful lot of water in those fire hydrant systems, potentially. Okay, so skipping through that. Any questions? Were there any questions on finding water before I go to the next section?
Nope, no questions at the moment.
Okay. Moving on, storing water, really straightforward. There's always a dozen ways of doing this, and everybody has their best way that works for them. We can talk about minimums, we can talk about water loss, and it's all there in the slide. If you're planning on 1 gallon per person per day, that's really kind of a minimum amount. But I would suggest that water is stored in multiple different ways. There's a huge advantage to having cases of pre-bottled water from the store in terms of distribution. If you have people that have to come over to your home in the summertime and help dig you out or dig your loved ones out, being able to hand off some bottled water is a huge benefit. Or if somebody has to do a search and rescue run out of your property to find somebody that's missing, being able to distribute water to a work crew is very handy and very portable. You can put water in containers. There's all kinds of commentary, and there's some of that down below on how to put bleach in it, store it. We typically just store the water. I don't have a lot of hobbies, but one of them is not rotating my water for sure. And so, it's not a job I enjoy. So we basically just throw our water in the containers, and then we plan on purifying it on the way out. It just keeps things simple, and we don't rotate it a whole lot. But each person can do it any way they like. And down below, we'll talk more about the purification and how to do that. Various containers for your go bag. And so we'll switch out to off screen share here. So here is my water component out of my go bag. And basically what I've got is a homemade bag. I've got Kevlar lining in here. So when I'm boiling water, I can throw hot containers back into a nylon bag and not have it melt everything. So cotton sleeve for making char cloth. And the idea is to have something that you feel comfortable putting on a fire to boil water. I think everybody should have at least one metal container in their kit, so that you can do the most simple water purification process, which is basically boiling. And having more than one is the key. All of my stuff has got dummy cords because I don't like losing my stuff. So everything is tied into the kit. And then I can obviously release that if I need to. And then down at the bottom of the kit, we've got other containers. So if I need to increase my capacity, this is where I go to the other containers that are expandable. And so I don't have to take up the space and weight that the metal has when we get past that. So going back to the handout. Sure. Thank you, Jen.
We have a quick question that I think is a good one. How long will purchased water bottles store? I've heard over time the plastic leaches into the water.
Yeah, so that's a really good question. And we had to study that really closely when I was in Iraq. Actually, that was a really big deal because the temperatures, getting up to 140 in the summertime, there were some issues like that. But in typical environments, like what we'd have around here, not those extremes, stored in your garage. Honestly, it's water. And if you're worried about BPA, then do something different. But unfortunately, when they do studies and they look at BPA throughout the planet, and they're measuring BPA found in urine, there's really no way to avoid it. Unfortunately, they've looked at people that drink out of glass jars and live that all natural lifestyle, and they have the same amount of BPA in their urine. They can find the same amount of BPA in the urine of people at the top of the Himalayas that you wouldn't think would be exposed to a whole lot of plastic in that environment, and they still have it in their urine. So we're going to get BPAs, unfortunately, living on this particular planet at this point. There's particulate plastic floating all over the planet. So can you get exposed to it from plastic water bottles? Yes. Is it got a higher concentration if it's stored in the sun? Yeah, if it's stored openly in the sun and it heats up a lot, you're going to get more leaching out. But in terms of what's more hazardous, not having water or worrying about BPA, I would argue not having water is a much bigger concern for me personally. But each person has to make their own decisions on where to go. Shelf life is pretty much indefinite. If you look at the way these factories run, that make this bottled water, it starts out as a little test tube of plastic, and it gets hit with hot air and blown into a mold. And then reverse osmosis water is dumped into it with no human contact. And then that is sealed with the cap. If there's going to be some flavoring, it's actually sprayed to the inside of the cap. They screw it on in the machine. It gets palletized, and the only guy running it is just dropping off the little, plastic test tubes at the beginning and using a forklift to pick up pallets of water at the other end. So it's really clean water. And I really don't see a lot of shelf life issues there. You can use it for wound irrigation and all kinds of things because it's clean enough to do that. So I hope that answered the question. If it didn't, please let me know. Okay, you can make improvised containers. And I think there was a question on what nesting container I had there that flashed across my screen there. This one comes from I think Wilderness Outfitters, Dave Canterbury's site, Pathfinder School. But it's one that I like. It nests very easily. It's got a lid that I have wired into the bottom here so I can flip it up to the top, and it's got handles. So yeah, okay. Let's spend a little more time there. So the clean canteen typically comes with a plastic lid, but you can buy the metal lids. And then when you go to boil, you take the little silicone washer off, and then so you don't burn it, and you go from there. Were you guys able to see what I was doing, or am I still on screen share? Shoot, it's hard to flip back and forth there.
You're still on screen share, but I think we could see good enough.
You got the idea. Okay. All right. So improvised containers. If push comes to shove, just remember those. You talk about bad plastics. Those black trash bags are pretty nasty in terms of contaminated plastic. But if push comes to shove, that can be shoved in a pillow, and you can fill that with water. Water beds. Again, the water in a water bed is pretty nasty, but if you find an old used water bed bladder, that's a nice big water storage device, in a pinch, if you know the water is going to go out here soon. You can fill your bathtub and whatnot as well, not to store water. This next section talks about setting up halogens, or basically bleach, in your water going into storage. And if you want to do that or choose to do that, you're targeting about 4 parts per million, and you use pool test strips to, they can't see right now. They use pool test strips to confirm the concentration. You can read the rest of that. It talks about food grade and non-food grade. When they're making buckets or making plastic buckets, if they have a release agent, they can run the buckets through the mold a lot faster in the factory, and so they're a lot cheaper. And so that's why there's a difference between food grade and non-food grade. Is it has this release agent all over it, and that is a plastic product that you may not want to be ingesting. But again, push comes to shove, it's not going to kill you today. So water distribution, I'm going to skip over a little bit. You can use orchard pumps basically with 12-volt solar panels to make water move from point A to point B, so you're not carrying buckets over long distances. And I'm going to skip over that because in the interest of time, I want to get into water purification and disinfection. So when you're talking about disaster water, it's a completely different thing than say hiking water up, up in the high mountains. And so, just picture open sewers. The water, the groundwater that's around you is extensively contaminated. I've had to, work in a place, well, Bangladesh is a great example. I've been there 6 times. And so, pretty much everything's a sewer. That's all everything is in that highly populated country. And so, everything around you is covered in pathogens, viral, bacterial. And of course, we know that viruses are very, very small. We know that bacteria are larger. And the key difference there is that viruses are difficult to filter out of water and require special treatment modalities. And we'll get down into that. The rest of these bacteria, cysts, parasites, algae, to some extent, you can build up toxins in highly concentrated algae environments that are hard to filter. And then nematodes are gigantic. You can see them in a child's microscope. So these things can make you sick. And so that's what we want to get rid of. If you want to do the water purification, the simple and the most simple, easiest to understand way is to boil water. It pretty much cooks most of those things and takes care of most of the pathogen problems. You're going to have to evaluate your source water for these other organic and non-organic chemicals, pesticides, petroleum. Is this a radiological environment, which has a whole different set of parameters for purifying the water? Is there arsenic in the groundwater in your area? These are really good questions to find out now before you get surprised later. And they have some different techniques to manage those. But most of the water problems can be solved by managing the pathogens. And so boiling is the simplest way. The problem, of course, is that it involves a lot of labor. And when we're talking about survival in general, what we're talking about is work. It's tasks. That's all it is. Shelter, water, food, all these different tasks need to be accomplished. And whoever can figure out how to do these tasks most efficiently, using the least energy and effort and the least time, will have the best chance for survival. You'll have more time to improve your position, or if you can get through these basic tasks quickly. And that's why we have all the rest of it. If push comes to shove, you can walk around in the forest and find a beer bottle pretty quick and boil water in it and call it a day. But it takes energy, effort, and it exposes you to risk because you're working around fire and you're cutting wood. And so you can get burnt or you can get hurt. And so if we can find simpler, faster ways, that's what the rest of this is really talking about. And so this table that I'm showing here, everybody should get a copy. Just the take home message here is if you look at all these different pathogens that are here, and Hep A is the troublemaker down there at the bottom. But if you look at all these different pathogens, they're killed at 70 degrees Celsius. And so just for reference purposes, which is also listed in the handout here a little bit below this, 100 degrees Celsius is boiling. And so well before you get to that point, you have killed off most of these critters. And so for all intents and purposes, heat is a very good method. Hep A, it can take longer contact times at those temperatures to be successful. Such as 30 minutes rather than these shorter durations. And Hep A is a troublemaker at 85 to 98 degrees Celsius, depending on whose study you believe, you can get it killed off in 1 minute. And most of the altitudes we're going to be working at, that's not too much of a problem. But the good news is when you get up around 14,000 feet, there's not a lot of hepatitis A because there's not a lot of people. So that's just the reality there. And so, but at lower elevations, you can get it by boiling the water. And simply 1 minute will get that. Filtration of microns. Hey, there's a lot of numbers there. Don't worry about it too much, except to note that as we get down here into the viruses, they're really, really tiny. And that's going to be important when we talk about filtration. And so in looking at the terms here, filtration is basically just screening out things. Think of it as a mechanical process. Chicken wire versus window screens for stopping bugs. It would be the example. Halogen is things like iodine or bleach solutions. And then UV is ultraviolet light. And we're going to talk about those. So we talked about that. There's your numbers just for reference. There's your boil times. And so the point here is you see a lot of people say, hey, it's got to boil for 5 minutes or 10 minutes, depending on who you believe. By the time you get it to boiling in most wilderness environments, it's been above 70 degrees Celsius for more than 10 minutes. And then you got your cool down time also. And so there's a thing called a WAPI indicator that's here, WAPI. And it's basically a wax that melts at specific temperatures. And that's a nice tool if you want to heat water in different ways, such as using a solar oven, or you're just trying to heat a lot of water quickly and you want to get to temperature and then get it cooled down without adding the extra fuel between 70 degrees and boiling at 100 degrees Celsius. And so the beige one melts at 69 degrees Celsius and the green one at 65. I'd recommend the beige one, and they're reusable. It melts, it drops to one side, it rehardens when it cools off. You flip it over and then add it to it hangs off a wire off the side of the container, and it melts when it hits that temperature again and drops down. So you can get a really quick thermometer read basically off your water. All right, we talked about that. Pressure cookers. And so Esther talked about the All-American pressure cookers. They're fantastic tools. If you're boiling water en masse for your family, a pressure cooker will really reduce the fuel consumption, and it keeps ash out of the water, which is another downside of boiling. Ash just tastes nasty, of course. And I like the All-American because it doesn't have a gasket that's going to get cooked on the fire. This gives you an idea of the temperatures that you're going to get in Celsius at various elevations. And you can see that anywhere on Earth, we're getting over the 70 degree point. And even up to 10,000 feet, we're pretty much getting the hepatitis taken care of. And then up to 15,000 feet, if you're up at the top of one of these really tall mountains, which I hope you're not that high because the air is pretty thin. But if you're that high, then you're going to need to boil longer. That's you just need to add more time to it. So filtration, there's various varieties of filtration that's out there. The one that we use and carry a lot is a ceramic pump. And so I'm going to be flipping. I'm going to show you guys these after I go through the slide. How's that? So we don't flip back and forth. Ceramic pump, the big advantage is it's fast. You can clean it. It has a very high capacity. That is to say, you can go 5 years on one pump and provide for all of your water needs, on one filter here. They're highly mobile. You can inspect them for damage and look for obvious damage. The downsides are, you got to protect them from impact. While they won't always crack when they freeze, they can. And they're kind of a medium weight. They're not the heaviest thing, but they're certainly not the lightest. Ceramic gravity is a little different. That's similar to the black Berkeys and things like that. And basically what you're looking at is a ceramic element, but instead of getting pushed through by a pump at high velocity, it's allowing gravity to drip through. You get additional assistance with that because of the colonization of bacteria that forms on the filter. And yes, those are not pathogens. They're bacteria that are helping you. That will actually impart a lot of antiviral activity. The downside is they're slow, they're stationary, and they're bulky. And there's ways of working around some of that, but in general, that's the scoop there. Nanotubules are basically very small tubules. Sawyer started with this to try to be able to filter viruses. They're very light. I say medium speed because while they may work pretty quick initially, they clog very quickly and they're very hard to clear the clogs out of. When you backflush, you're only partially cleaning them out. You're not getting full flow again. And you know, they claim to filter viruses, and that's good. But again, you're not going to see that long duration in the long emergency of being able to do that. And there's no way to do a quality control inspection on that. Plastics degrade over time. They can crack or break if it's been sitting on the shelf for a very long time. Paper filters are light and cheap. That's what a lot of people are using for ultralight backpacking. You can get several hundred gallons through it and get some filtered water, and then it's done. And so they're light and disposable. They're inexpensive. I think they're a trap. And along those lines is the paper straw filter down there at the bottom. It's light and cheap, but anytime you're sticking that in your mouth, you have no ability to do secondary decontamination for viruses. And so that's I think a bad idea all the way around. And so people talk about, you know, do you like the Sawyer straw or do you like the Life straw? And I don't like either one. I think they're both very, very hazardous in these environments. Reverse osmosis is expensive. It's slow. It wastes water. If you put it into storage after it's been wet, you got to have a special storage solution to put in it. Otherwise, it grows algae and things in it that will clog the filter. But it removes almost everything, not everything, but almost everything. Cloth and sand improvised filters, better than nothing, but they will improve with time as they get colonized. And you know, they can remove a quantity of pathogens. And again, when you look at getting sick, it's not a matter of I got one bacteria. Well, that won't get you sick. You got to get enough quantity that overwhelms your system, and that's what gets you sick. So if you can reduce that quantity, you'll at least reduce your illness or potentially improve your outcome that way. When you're making a sand filter, you know, we talk about the pant legs, you know, filled with sand and things like that. Unfortunately, the water preferentially flows between the walls of the container and the sand. And so as it's wicking down through there, you're not getting good filtration. So it needs to be like a 55-gallon drum in diameter. And run the water slowly through that. So let's skip past that, and I'm going to show you some filters. So we're gonna stop sharing. We're going to go through this. Can everybody see me again?
Yep, we can.
Good. All right. So going through them, here are some ceramic filters. So this is a Catadyne. This is the Pocket. This is the older model. It's got this little metal spout on the tip, and you can pick these up on eBay or other places typically for, they're running around $100 right now. They used to be around 70, but they've gone up with you know, the world and the way it is. Brand new, they're in the $350 range. Here's a newer model, and I like to show this one. So the newer model has a port where you can actually attach another one of these hoses, which makes filling your container easier. These basically pump and do their thing. This one had a failure of the one-way check valve. And so in your spare parts kit, you go to Catadyne and you pick up all the different O-rings and things like that. In our water bag over here, we've got extra silicone to coat these O-rings. But this is a one-way check valve they're very inexpensive. You can buy them as a spare part. And so if your water filter has a failure like that, you can just plumb that right into the system and make your own check valve to replace the one that failed in the system. And so that's the way to do it. This is a nice thing to show. This is how you get the water from the correct depth in the water. The inlet is screened and weighted, and then there's a float. We like to take either coffee filters or there's water sock type filters and pre-filter the water before it goes into the unit if there's any silt or sediment in the water, just to try to preserve the unit. But these are really easy to take apart. And like I said, this is like 5 years worth of worth of ceramic filtration for you. That's a lot of water you can push through that thing. But you can clean it if it's covered with silt. If it gets contaminated or dirty, you can just wash that off and start over. You can't do that with some of the other designs, a paper filter or nanotubules. They're not going to do that for you. And that's why, even though these weigh a little bit more, I think this is the better solution for what we're discussing here, is this type of filtration. Okay. Black Berkey, we store it in a bucket to protect it. And I'm going to set this down and pull the actual Berkey out. And so, well, maybe I won't get the whole thing out for speed here, but basically you've got two containers, one on the top and one on the bottom. And you got these little ceramic elements that are stored in these boxes right now. And those ceramic elements plug into the top of that thing. You pour water in the top and it slowly leaches through the ceramic elements and drops to the bottom. When you're initially setting up these filters, it works better if you can pressurize them full of water from pressurized tap. And so that's sometimes a challenge in an off-grid environment. And so, one option there is to, again, have the orchard pumps to be able to generate some type of pressure to fill these full of water. And Electronic Gold Mine is a website where I typically get those types of pumps. They're just inexpensive. If you've never seen them before, I don't know where you've been, but these are the test kits, test strips for checking the pool chlorine levels. For your everyday carry water purification, here's some water pure tabs that you can throw in your pocket kit. This, I'll get there. This is a Cat9 mini as opposed to the Hiker. The Hiker has paper. This mini is a little small ceramic filter in it, similar to the ones we just showed. It's just smaller and goes slower. So if weight is an issue for you, that's where I would downgrade to. Okay, flocculation. So what flocculation is basically using chemicals to take all the particulate matter in the water and clump it together and have it drop down to the bottom. These guys seem to usually have the best price. They sell nuts, but they also sell alum powder. And if you get in some water that has a very high organic content or a high debris content, you just take a pinch of that to the gallon and shake it up real good. The instructions are here in the handout, and then wait about an hour for it to settle. And then you can either pour off the top water or you can pump it off. You can remove about 60 to 90% of your pathogens just by clumping them all together and having them settle. And so it's a legit technique on its own, but typically it's a way to augment filtration for really bad quality water that you're starting with. So I'm going to go back to screen share here. Whoop, I screen shared the wrong thing. Hang on. There we go. All right. Halogens. Okay, so if you're going to store bleach, liquid bleach that you buy in the grocery store will work. However, the shelf life is very, very poor and it degrades quickly after about 6 months. Calcium hypochlorite, also known as pool shocket, that does not have a copper aldehyde in it, will store well, but remember it's very caustic. It will off gas right through your plastic bucket. If you store it next to metal items, they will rust. That's why people have pool houses, to store these nasty chemicals in away from the house. But they do have a much better shelf life. There's instructions in here on how to mix it and use it. And we'll talk about the parts per million, which we test with the pool test strips, and time frames and temperature. There's a little table down here that we're going to go over. Chlorine dioxide is a chemical that is sold in hiking and camping. It has an advantage that it kills Cryptosporidium, better than standard bleach, which is a nasty little pathogen from poop. Unfortunately, it's toxic in pregnancy. And iodine long-term can create problems in pregnancy, but short-term use is okay. This is a real couple of last 2 minutes take-home questions here, or take-home information. The chlorine parts per million. You can see based on the temperature of the water that the range of time frames is highly variable from 15 minutes to 240 minutes. And so, be advised that these standard, things don't really work. There's using the calcium hypochlorite. And here's some examples of halogen demand. So, we talk about cloudy water versus clear water. Well, that doesn't make any difference. When you look at, Colorado River water, hardly any bleach will purify that because there's no organic matter, versus say Columbia River water, which looks a lot more clear, that takes 3 to 4 milligrams to the liter, a lot higher quantity. It's because it's burning up the organic matter. The higher the organic content, the more it's going to take. Last two things I'm going to go over real quick is UV light and SteriPens. And so a very quick way to get that secondary treatment done is UV light. And so give me about 1 more minute and I will wrap this up. I'm getting my time here. And so these little SteriPens, they work quick. In a minute or two, you can wind up getting your secondary decontamination, killing off the viruses. And so that's our other primary tool that we use. The Catadine combined with SteriPen is our primary goal. Another option is Myox pens, which is a mixed antioxidant solution. And the community version of that, which is good for huge groups, is the SE200 community chlorinator, to do 55-gallon drum amounts of that. And that's all I've got opened up for questions.
All right, you've got a lot of questions, so we're probably going to just put a bunch of those onto the document and have you answer them. There's a couple that I think would be good to cover real quickly. Does diatomaceous earth help with any of this?
You can use it as a filtering element in your sand type filters. It's an excellent medium, but it's its primary goal is to kill insects and parasites. So it's just a fine filter medium.
Okay. Is Polar Pure? Do you know about Polar Pure? Is it a good chlorine dioxide?
Yeah, it's another halogen, and if you get the right concentrations, you're going to do great with it. So.
Okay. How about nano silver? Can you use colloidal or nano silver to purify your water?
Yes, with caveats. I think of it more as bacteriostatic. And there's some downsides to using silver. I know there's a lot of people that like to drink that stuff. And, here in Southern Oregon, I have had several patients that were blue. So from drinking too much of it. So, I don't typically think of it as being particularly a great option for ingestion. Other people would disagree. I think that it's valid to use as a bacteriostatic solution. So if you took a metal container and threw a coin in the bottom of it, a silver coin that didn't have other metal contaminants, that was pure, you could even melt that into the container if you wanted, and you could get some bacteriostatic benefit from that. But as far as, putting, significant amounts of colloidal silver into drinking water, yes, you can purify water. But I'll leave that up to you as far as the safety piece. So,
Mike, this is Dave. Do you have that broken Catadine filter you could show people what it looks like inside? Is that handy on your bench?
Oh, the shattered one? Yeah, Jen's running
the shattered one, so you can see the rocks and what the ceramic is actually made of, because most people probably haven't seen the tested one. Yeah,
we had one that arrived with no bubble wrap in a paper sack via mail, and so that didn't survive. They are fragile. So here's the container it came in.
They also freeze.
So when we say you can inspect it, I don't think this one's going to work. It's You can have micro cracks, but you know, if you examine it closely, you'll see those. This one's obviously, you know, catastrophic destruction here. And then the innards of it is I don't know if you can see that, it's a silver impregnated sand. So too much light. I don't know, it's glaring there. But anyway, that's the big expedition model.
Yeah, so basically it's got a bunch of rocks that are silver impregnated, do kind of like your silver treatment like you were talking about before with a bunch of ceramics. So it's kind of interesting to see it. Really, it is a synthetically grown ceramic that's quite fragile.
Yeah, the goal of the silver impregnation.
All of a sudden, we're losing you. We haven't had a problem the whole time, but we lost your audio, Mike.
Oh, yeah. The goal of the silver in these filter elements is to prevent over colonization of bacteria or algae and things like that. Did we lose me?
Nope, you're back. Perfect.
Okay. Yeah, the silver in these elements doesn't necessarily take on the viruses or the bacteria itself. It's to prevent overcolonization. Iodine matrices was something that was out in the 90s that also doesn't really work very well in actual performance. And so.
Okay, thank you so much. This has been a lot of really great information. There's still a bunch of questions. So there's a lot of questions about brands and, you know, where to get things from. And so we'll send that all to you and you can answer those questions and share them with everyone.
Yeah,
I think that's going to be
Catadiene and SteriPen. If you wanted to go real quick, easy and simple, get a SteriPen and get a Catadiene pocket. And or if you're stationary, get a black Berkey and you're set.
great. Great. All right. So much good stuff. Thank you. There's just never enough time to get everything going, to get everything that we need to learn. But this, I think, has been a really great primer and an introduction into what people really need to know, and then a starting point for acquiring things. Very good.